All right, here's a couple of good limiting reagent questions. Reaction of magnesium plus hydrochloric acid will produce magnesium chloride plus hydrogen gas. And this is aqueous. I looked that up earlier. I need a 2 here, and I think I'm balanced. So they say 3.2 moles of 9 moles of this, and the same number of moles of this one. How many moles of excess reactant are left? So we have to figure out the limiting reagent first. So you can pick this one or this one, it doesn't matter. Let's pick this one. So if I have 3.29 moles of hydrochloric acid, it needs to react with, not HCl, sorry. I said start with this one, of magnesium. It'll react 1 mole of magnesium, that's that number, reacts with 2 moles of hydrochloric acid, that's that number. So if you double that, that'll be 6.58 moles of HCl, and that's required. Okay, but I only have 3.29 moles. That's that one. So therefore, HCl is limiting. It's the limiting reactant. So you're going to have magnesium left over. So to figure out how much magnesium reacts with this, I can do the same thing as this one, but use HCl. So let's see how many moles of magnesium are used when all the 3.29 moles of HCl are consumed. Sorry about my writing. Okay, so to do that, I take the moles of HCl, 3.29 moles of HCl, and multiply it by 2 moles HCl react with 1 mole of magnesium. So if you multiply and divide that, I think you'll come up with 1.645. I don't know. 3.29 times 1 divided by 2. 1.645 moles of magnesium. So that means that if I use up all of this, it requires that many moles of magnesium. And when I look up here, well, you might not be able to see that. When I look up here, I've got plenty. I've got 3.29, and here I needed 1.645 to get rid of all the HCl. So to figure out how much is left over, that's what they say, how many moles of excess reactant are left over. So then I'll say, well, I have 3.9 moles of magnesium to start. If I use up 1.645 of that, moles of magnesium, then I'll be left with whatever 3.29 minus 1.645 is. And I think it's the same number, 1.645 moles of magnesium left over. Usually when we do this reaction, we have plenty of hydrochloric acid, so all the magnesium goes away. But in this case here, the magnesium, some of it would get eaten away, but all the hydrochloric acid, because it's a limiting reagent, all that would get used up and there'd still be magnesium left. Here's the same question, but with different numbers. I was just looking at what was written here. And this is perfect. So this stuff here is bang on. So magnesium is your limiting reactant. So what you have to do is figure out, so that's how much HCl is required, and you have this much, so you got way too much HCl. So in order to figure out how much magnesium you need, let me just look. Yeah, and magnesium is your limiting reagent. So, oh no. I think you've done the work right here, but I don't think this is right. So if I have 4.14 moles of magnesium, it requires 8.26 moles of HCl. That's right. But you only have this much. So if you only have that much of HCl, you don't have enough. Therefore, HCl is your limiting reactant. So if HCl is your limiting reactant, then you can do your mole ratio to see how much of magnesium it'll react. So, or it'll need, or it'll take away. This is the case. This is the same as the last one. So 4.13 moles of HCl, so 2 moles HCl react with 1 mole of magnesium. So 4.13 divided by 2, 2.065. So 2.065 moles of HCl. That's how much will react. Hold it. These cancel. Moles of magnesium. That's how many moles of magnesium will react. And you take a look, and you've got more than that. So if you have more than that, then some of this magnesium will be left over. So to figure out your leftover, go 4.13, this is what you have, and subtract the 2.065, and that's how much reacts with the 4.13 moles of HCl. So when you subtract those, you get 2.065 moles of magnesium left over. So you put the magnesium in, it'll all bubble, the hydrogen gas given off, but you're still going to have a strip of magnesium left over. Okay, hopefully that helps.